Welcome back everyone. So the topic is tangent. In the introductory lecture of circle, I discussed about the situation of line and a point as well as a circle, right? We discussed multiple scenario. So for example, there is a circle and there is a point inside the circle. Let's say this is O, my center, and this is a point P right over here. Now from this point I can draw only various chords. For example, this is a chord, this is a chord, this will also be a chord, right? These all are what? Chords only. But if this point is, this is my O, if this point is on the circle, this point is P, then at this point I can draw a line which is just touching the circle, and that line is a special line known as what? Tangent. So if a point lies on the circle, then we can draw one straight line just touching to the circle, and that line will be known as tangent. Now you must be wondering how many tangent can be drawn. So there can be infinite points lies on the perimeter of the circle, and that's why infinite tangents can be drawn. For example, there one tangent such can be drawn such like that, right? Similarly, another tangent can be drawn like that also. Now what about the point is lying outside the circle? So if point is lying outside the circle, let's say this is my point P and this is my circle with the center O. Now as you can see, we can draw one tangent right over here and another tangent right over here as well, right? So if point is outside the circle, there can be two tangents can be drawn. Now this was just the overview of tangent. Now let's understand few important theorems related to tangents. So the theorem number 1 related to tangent is, for example, this is a circle and this right here is a tangent, and this is my O, this is my P, and this is my radius. Now the theorem is radius is always perpendicular to the tangent. Radius is always perpendicular to the tangent. That is, this angle right here is 90 degree. And if you want to understand the proof of it, that can also be doable. See, radius is what? One straight line, and straight line is all, or you can say radius, the center. Radius is what? The line joining to center to that point. And if you consider another point from here, such like somewhat like this, or you consider another point somewhat here like this, or you consider one more point like here or like here, right? All of these distances, as you can see, in between all of these straight lines, radius is the shortest one. And the theorem, this theorem, what we studied in lines and angle while we studying lines and angle, that the shortest line between a point and a line is always perpendicular on that line, right? For example, this is a point, let's say P prime, and if I join this line, what I will be getting is a perpendicular only, right? Why? Because this is the shortest distance, right? There cannot be any other shortest distance between this point as this line, right? So this will also always be perpendicular to each other. Next theorem what we have is, let's say these two are somewhere meeting, intersecting at this point, right? Let's say this point is A. So the next theorem what we have is length of tangents drawn from outside, from a point outside of circle is always equal, will always be equal. That is what it wants to say, that the length of the tangent, see PA is a tangent and P prime A is also a tangent. So as per this, what it is trying to say, that PA is equals to P prime A. This is what, and this is what we have to prove, right? Let's understand the proof of this, which is pretty much basic. All you need to do is just to draw one triangle right over here. So what I have done, I have constructed a triangle. Now in triangle OPA and OP prime A, what I can say, that OA will be equals to OA, and also this angle is 90 degree, this angle is also 90 degree. So OPA, angle OPA is equals to angle OP prime A, and obviously OP will be equals to OP prime, and from this I can say that triangle OPA will be congruent to triangle OP prime A, and if this is true, then from here what I can conclude, that respective sides will also be equal, that is PA will be equals to P prime A. I hope it makes sense to you. So the next theorem what I have is the corollary of theorem 3 only. So this will be theorem 2 only. So in theorem 2 what I said, that if I draw two tangents from a point outside of a circle, then the length of those tangents are equal. Now in this theorem 3, what it is being said, that let's say this is a circle and I draw a quadrilateral out of it. Let's say this is a quadrilateral, and let us assume that this is exactly perfectly touching the circle, right? So in that sense, all of these sides will be acting as a tangent. Now let's say this point is what? Let's say P, Q, R and S, and over here we have O as the center. Now from here what I can say, that this is a point which is outside of a circle and the two tangents are being drawn. So if this length, if I talk about this particular length, right from, let's name these as well, A, B, C and D, right? So if I talk about this length PA, if this length is alpha, then this length will also be alpha. If this length is beta, then this length will also be beta. If this length is, let's say, gamma, then this length will also be gamma. And if this length is delta, then this length will also be delta, right? So essentially from in this figure, what I can say, that if I sum up all the things, that is alpha plus beta, then beta plus gamma plus delta plus alpha. So what I will be getting is twice of alpha plus beta plus gamma plus delta, and this will be equals to what? See, what I have is thus, see, this is alpha plus beta. Similarly, this is what? Alpha plus delta. Similarly, this is what? I have alpha. If I just only look upon alpha plus delta, so this will be what? PQ. Alpha plus delta. That will be what? PQ, and then plus QR plus SR and plus PS, which is, because see, alpha plus beta, what I have is alpha plus beta. If I look upon alpha plus beta, this is what? Sorry, this will not be twice. This will not be twice. Right. This will come as it is. Alpha plus beta is what? This is my PQ. Beta plus gamma. Beta plus gamma is what? SR, and then QR, and then PS. So this is one important standard with respect to the tangent of the circle. You just remember this, right? Many a times this is being asked in the questions. So the next theorem what we have over here is with respect to the, that is by theorem 4, and which is actually relating tangent and chord actually. So what is the theorem over here? The angle made by chord and tangent is equal to the angle made by chord, that is chord in the circle, angle made by or angle subtended by. So what it is trying to say, let's understand. For example, this is a tangent right here, and this right here is a chord. So this is my PQ and this is my RS. Right. Now, what this theorem says, if this angle made right here is theta and this chord subtends an angle at this point somewhere, then at any point, you know, the angle subtended, if somewhat like this or somewhat like this, all the angles subtended will be equal by this chord RS in this segment. So this angle will also be theta. I hope it is making sense to you. So we can easily look upon the proof of this as well. In order to prove that, what I am going to do, I am just going to drop I'm just going to join this is my center, right? And let's join this as well. So I can see OR is equals to OS, that I know. And if I say angle ORP, that would be what? 90 degree. This would be ORP. That would be what? 90 degree. And if this angle is 90 degree, then this angle right over here will be what? ORS. Angle ORS will be what? 90 minus theta, because this complete angle will be what? 90 and this is theta. So this will be 90 minus theta. And let's join this point as well. So this point right here will be what? Let's name it PQRS T. I have named this one as T. So as I can see, if this angle is 90 minus theta and OR is equals to OS, so this angle will also be equals to OSR. Or rather, if this angle is 90 minus theta, So if I talk about angle ROT, this angle will be what? Theta, because this is already a 90 degree. What I have done, I have dropped a perpendicular. OT is perpendicular to SR, right? So this is 90 degree and this is 90 minus theta. So this have to be theta, and if this have to be theta, this will also be theta, because these two triangles are congruent. This OR is equals to OS, this is common, and this is 90, so obviously these two triangles will be common. And if this complete angle is 2 theta, then this angle will be theta only. That is, angle ROS will be what? 2 theta. So the chord, the angle subtended by chord on the center, if this angle is 2 theta, then this angle have to be theta, right? The half of which. So angle TU, let's name is U. So angle RUS will be what? 2 theta by 2, that is theta. And that's how we have proved that if this angle is theta, then this angle will also be a theta. There is a one small result associated with that, and that is, let me draw it in another circle. That is, let's say this is a circle, and again this is a tangent, and let's say this is a chord. So as I have told you that this chord is subtending this angle. This angle, if this angle is theta, then this angle is also theta. Now if I join and make this one triangle right over here, so if this angle is alpha, this angle will also be alpha, and that can be proven by the same logic that I have just given you. So just remember this one, right? This is completing both the results. I hope it makes sense to you, and that was all about the introduction of tangent and important theorems. Next we have is length of tangents. So we will be doing in the next lecture. That's for this lecture. Thank you so much.